Okay, welcome back to this Codevember number 23. We are still exploring the way of interpreting body using creative coding. We've made various experiments since the beginning of Codevember. We're reaching the end of Codevember, and as I said last week, I'm not sure I will be able to pursue this until the end because I'm still thinking about taking some times to simply just try to debug some of the scenes and finalize the art direction and finalize everything in order to have a uniform experimentation. And this is the one we've made yesterday. So this is the one we made yesterday. It seems to work. The idea was to work on the growth, so something going from the inside and growing and turning on himself, etc. So on this one, we have a little bug which seems to be happening when we changing loops. I first I thought it was a bug of plane which were on the same on the same z, on the same coordinate. So if two planes are on the same coordinate, you might have a problem when deciding which color you want to display, because the two planes are on the same place. And I thought this little glitch we have here, especially when I'm turning here, you can see them. I thought this was that, but I'm not sure anymore. I think it might come from something else, because the more we changing the loop, the more we have this glitch. So it might come from something else, but I'm not sure why. So yeah, maybe this will be something to debug in the next day. But today I want to continue experimenting on a new body interpretation. And yeah, there's something I want to try since a while. Something is quite simple in fact, but can be also quite complicated. Is playing with vertex displacement. We already played with vertex displacement once, but the main idea is to basically make a big bubble man, so we will use a sphere for that, and not too much sphere, I think. And we will add some kind of a big bubble man, something like the first bubble man we made, maybe a little bigger. And the idea was to simply, for each instance, try to use a noise in order to displace the vertex, in order to get something a little bit like a soft body. It will not be a soft body, because a soft body need to react to the physics, so it's with something look like a soft body behavior. So this, using vertex displacement, it's quite easy, because you take the normal, and we are in a sphere, so it's really easy. So you take the normals and you simply push the vertex along this normal according to a value, and by using the noise you will have this nice jiggly shape. Something which is not quite easy in fact is recomputing the normal, because if I take the shape, so a sphere, so each normal are quite simple, because it's simply the vector going from the vertex to the center. Okay, so for a sphere it's quite simple. But if now I'm simply deforming the sphere like something like that, you have a shape like that, then the normal will not be the same So we need also to compute the normal, and computing the normal after a vertex displacement is not that easy. There's various way to do that. There is a way using some derivative function using ddfx and ddfy, which work in processing, especially because it's your GLSL, so it's really interesting. But it gives some kind of flat surface. So if I want to have a smooth displacement, it will not that easy. So that's the main idea, having something like a soft body made of some kind of soft ball. And in terms of the material, I think I will go with something more like a fabric, something colorful, but a little bit of fabric with some normal mapping, etc., etc. So let's do that. So first of all, go back to our little scene here. We will need to change every element we have. So duplicate the material, of course. This is the first part. It's quite easy. Duplicate the compute shader. I'm not sure we will use the compute shader. I think we will use the compute shader to redefine the position, but let's duplicate the two materials. And I think we will clearly work on the vertex shader side. Okay, so I need to open this one because I need to rename it. And we need to duplicate the controller and the GPU mesh controller. Okay, so it would be 23. Okay, now we will open the GPU mesh controller here, rename it so it will work. Okay, and now 23. Okay, let's wait until it's compiled. Okay, we can now use that. A controller, a GPU mesh controller. We can get rid of this and this. Let's start with not too much instances, and I think we will not have too much, in fact. In order to select our mesh, we will start with a simple sphere. This one is interesting. Let's say 0505 111. The notation, why not? And let's put some color into it. Take our compute shader. We'll take our ramp. Where is our ramp? In the ramp here. Okay. And for the material, it's 1123. So I need to change that, of course, by taking our new custom. So let's go back here, take this one. So basically by doing that, I will have the same experiment than yesterday, because it's for everything a duplicate. Okay, but with this bubble man. as you could see, we start seeing some of the glitches I was talking about. Now we have more than here, here, we have some glitches. Okay, but the glitch will be for the debugging phase. So go back to the shaders. Tuk, tuk, tuk. Let's simplify everything. So we have a target size, and the target size will be our final size, so let's call this size, and we don't need all of this right now. We can use the rotation, so scale, transform, and let's say the color is 1 for the moment because we use a discard, so it's okay. This we don't need also. So this is the base. Okay. And if you want to have less elements, let's try. Okay. 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 Looks interesting to me. As a shape, it looks interesting. So now the main idea is to displace the shape using a noise. So let's try to do that. Yes. Okay. So yeah, go back here and let's try to change our little guy behavior, and for that we will need to change the shader, of course. So we could go to the vertex shader, and here it is. Okay, so we will work on that. So as I said, the main idea for displacements is taking the normal and then offset along this normal using the noise. How can we change the noise? The most, I think, easiest way would be to use the noise function we have. We need to change this include in order to go here. So if I include my vertex shader, yeah, if I include the vertex shader last, I will be able to use all this function here. So let's try to generate a noise. For example, we will put something like that. So for example, let's say noise displace. So this could be something like I think it's the function is its noise, which can take a vec3. So the main idea is to, for example, let's use a sine function. Okay, so a sine of this. So this would be the sine would go. It's a function which go between -1 and 1. Okay, so if I want to be able to have only value going from 0 to 1, I would say something like that. I would take the absolute, so I will go from 1 to 0 to 1. Okay, so this is the value I want to displace my vertex. So it will be the same for each vertex. So now I can simply, for example, take the flow3 vert displace. We could name it like that. So this could be v dot normal. So we take the normals, multiply by the noise displace, and then I could say v dot vertex plus equal this vert display. So by doing that, I will have all the shape growing and grow down, you know, using the sinusoidal function. Flow2 to flow3, yeah, cannot convert implicitly, says yeah, because vertex xyz vertex is a vector 3, but the vert display is a vector 3, so I need to respect the number of components for each vertex. Okay, let's try that. So now, as you could see, we're growing, growing, small, grow, small. So this is the main idea behind. So now we want to simply change this by taking a noise value for each vertex. So how can we do that? First of all, the first thing we could try is simply check a noise based on the vertex position. This could be a solution. Okay, so we could say something like that. We could say s noise of vertex dot xyz. So this could be a solution. Again, I will remap this, which go between -1 to 1. So I will remap this into 0 to 1 by using another tricks, which is simply taking your value multiplied by 0.5 plus 0.5, which return your value between 0 to 1 if your original value is as a range between -1 and 1. So this could be a trick to change the noise. Where did I make a mistake? Vertex represent a function, not a variable. Oh yeah, vertex. I forgot to take the input. Okay. So now you could see the way it's changing. Okay. So of course we have also this rotation. It's clearly far from perfect. Let's try to get the same element for the same for everyone. So now you see the noise. So this is basically the idea behind that. Okay. So let's continue our little journey. Of course, we could change the multiplier here to change the way the noise will be applied. So maybe we could change again the size and get less element, just to focus on the way we displace our element. So now you could see the displacement. So something interesting with the displacement is the normal is not correct, of course, but because we are using an ambient occlusion, it's the ambient occlusion make the tricks. It can do the tricks by simply sample some shadow directly into the shape. I was not thinking about that, but it might be a good trick. Of course, another thing you might notice is that the vertex displacement is of course dependent of the I will scale up a little bit in order for you to see. The vertex displacement is of course dependent of the number of vertices you have per meshes. So let me show you the shaded here. So here you can see, so the vertex displacement is like that because we don't have too many vertices in our little shape here. Okay, so that's the idea. When I talk about having not a proper lighting, and so because the normal are not recompute, let me show you. Here we can see that, as you can see, we have some kind of a directional shadow here. Basically this comes from the fact that our normal are not recompute in the vertex shader, so the lighting is not computed correctly. So if I'm disabling the ambient occlusion, okay, go back here, you will see what I mean. Without the ambient occlusion, now we clearly have a lighting problem. With, it's kind of good. Okay, so let's now focus on our own system. I don't want to use the vertex, also for the noise, and also we also have another thing that I'm not sure you've noticed that, but if we disable the rotation, you will notice that every little shapes has clearly the same displacement. All is the same, and it's normal because um, we have this things that it's take the vertex from the vertex position. In fact, I might think some. No, yeah, it might be the same because the vertex are in a model space and not in the world space. So here, because we are in a model space, if I understand correctly how Unity work, if we are in a model space, everything is relative to the origin of the shape and not the origin of the world. So that's why. But yeah, I think it might be more interesting to use the text coord instead of the clearly the unit the vertex. So what are the text coord? The text coord, I think, are something like that. Float to text, float to UV, and the UV are, let me see this. Let's check the Unity app data full. Unity app data full. I think this is it. So the app data full gives the position, the tangent, the normal, and 4 texture, coordinate, and color. So this is the position, the normal, the text coord. So I think we might have end up with something calling simply text coord 0, text coord 1, etc., etc. So we could say float UV is simply equal to v dot text coord. Okay, and you know what, let's create a vec3, so we could use that plus maybe the time, for example. Let's scale down a little bit the time. So we have now our vector 3, and we could use this UV basically in our noise, and we will need, of course, to scale it a little bit because UV are going from 0 to 1. So I think I will need to be, yeah, I will need to scale everything. So I could use something like scale UV, and let's take something like 20, for example. So now I could say this multiplied by scale UV. And it's scaling the time, of course. So the scale UV might be better here, and not, so it's not be applied on the x-axis of our new UV. Okay. Looks like we don't get the UV properly. We could end up with something different, but it doesn't seem so. Might need to transform that, I think. I was not sure I will need to transform, but maybe so. Let's go back. try that. Now we have an incorrect number of arguments. XY. Where do we made a mistake? Time dot y. Time is a vector. Okay, now it's working. Perfect. So it was a problem of the way I was constructing my vector. I'm a little bit tired today. Let's say 1. So now you could see this is less. Okay, so let's try 2 for example. I think we have a theme problem. How can I have something like without any theme? Let's try to say something. Plot gets UV text coord 1 dot xy and let multiply by 2 minus 1 in order to recenter this. So now if I'm scaling up the UV, I do have the same value on the X and the Y axis. Okay. Okay, I'm not sure about that. Maybe it's better to use the UV as to use the vertex as the UV vectors, or maybe something like that. Look like it's more interesting. Too much element, but much more interesting. So now we could also say, so this is the noise displace, so let's say let's call it a simple noise, in fact. And let's use a factor for the displacement, so we could say something like 0, 0, 1. This and this. So the main idea is to not going too high on the normal vector, to have some kind of jelly system. Yeah, something like that. So if we go back with something more bigger, now it's clearly more interesting. Can reduce a little bit this value and increment a little bit the noise. Okay. So of course you might notice some artifact here. On some place we have a little bit of artifact, but I've seen it here. So it's not perfect, but you know it works. So let's try that one. And if we want to have a noise really different per instances, I think a good way would be to introduce to our noise system here, to our UV, we could simply add to the base UV we will use, in fact, the position. Okay, so the position of our instance. So first of all, let's create this. So let's say float 4 o dot pose is basically equal at first to float 4 0 0 0. So if it's not an instance one, we will not use it. So pose. If it's instance, we're taking the position basically. So now we can simply say that we use the vertex and also we displace to the position of the instance. So by that we can have different noise per instances. Or not. Did I make a mistake somewhere? O.oppose.xyz UV float 4 0 0 0. If I do that, It's okay or not? No. Expect it to can. I made a float, but this value already exists because we've declared it in our struct. So of course I don't need to declare a new float. So now it's kind of better. We still have little glitches somewhere. And it seems it's because of this. I think it's because of the seam of our shape. Not sure, but let's look at it. So here we have a little spike. This here, okay. Do we have another one somewhere? I think we also have one spike here. We still have our little guy here which seems to have a problem. Not sure why. Looks like we have multiple elements on the same position, but okay. Of course we could increase that in order to see more our noise system. So now we see our problem here. So this was basically the idea I had in mind, without the glitch here, which I clearly don't understand. But if I say something like we want 100 of elements, we have a lot of glitches. So I think we will have something like that. So it will be this and this. So we still have a little problem here. Let's try to change the model and go back with the base model from Unity. Still have a little glitch. Now we see it. We've seen this problem here. We have a scene problem. again here we have the same one, we have the same here. A way to avoid this problem, I think, is to make a seamless noise. So I think I will need something like a seamless noise. Okay, let's use the time here to scale this a little bit. Okay. So right now we don't have too much glitch as we already thought. Sometimes we've seen the glitch, so as you can notice we have some of them, but sometimes not. So let's try to find some. This is quite interesting because I thought because we had this vertex we will not have a visible seam because the vertex returning to their position. But it doesn't seem so, as you can look. Let's try to create some kind of symmetrical noise. It will not be seamless, but it is seamless, but it will not be perfect. We still have some glitches appearing sometime. You could see sometimes we have some. I don't know why we have this. Little spike appearing here. We could also check another noise. Because I use the simplex, but I can use another one. This one, for example, returning value between 0 and 1. Of course, because I said this, we call this v noise. Okay. Okay. I think it's more. This one is more interesting. The noise. Using the noise instead of a simplex noise might be a way to avoid our problem. So this is quite convincing, in fact, especially because we have the ambient occlusion, so we might simply end up here. And we could try to also scale the basic shapes using some kind of growth system, and we won't get we won't focus on the normal, and I think that might be the trick, in fact. Yeah, I think I will go with that, because here's our problem. Let me show you. Okay, so basically what we've made is simply that. Okay, but the normal is not correct, so we still have a correct on the shadow. It's okay, but on the lighting it's clearly not correct because it seems at a pure surface. But here, this is why we have this little problem here. It's because the deformation is not too much prominent. It's more difficult to see that the light is not perfect, and especially not accurate. We can still see a little shadows, etc., etc. So I'm not sure about recomputing the vertex. There is an idea explained in the post I've shown you here, when you need to calculate the slope. So we need to sample the noise on different offset position and calculate the difference. So basically it would be to get the noise near this vertex. So it might be something like that. Let me think about that. This might be really really easy by using the UV. Sampling the noise on the UV, it could be easier to simply retrieve the new normal, because we can simply, we know the next UV, of course. It's the UV plus or minus the texel, which is not the same with the vertex position, which is in 3D space. So I'm starting considering using the UV again, because we could find that. So let's try, because we change our system, and now UV can be based on this. Okay, so if I said that, let me go back here. Okay, so let's continue our little exploration. It might be interesting to correct the lighting, but it's 22 p.m. Maybe just giving an hour to that might be interesting. Maximum an hour for the lighting and the animation. Again, I think I will go, of course, for the animation with beautiful noise elastic. With this kind of shape, it could be beautiful. Okay. Okay, so this was the problem. So remember, this is the problem because we don't use the same, we use our old sphere, which was based on icosahedron, and remember we had the same problem. We had reviewed this when we used these experiments. Okay, so now we can see the problem. We have some sim problem, of course, because we're getting some difference directly into when we scale the UV. Okay, so that's why I didn't want to use the UV, but we could sample this differently. How can I say that? Let's try to think about that. I think I can find a way to recompute the normal directly, because we are on the sphere, so the sphere is some kind of shape which is quite easy. In fact, let me go back here. So we have this, we know that, we know the vector, so we might need to change from 3D coordinates, from spherical coordinate to some other coordinate. So where did I make a mistake? Scale UV, vertex, oppose. Seems okay to me. So the spherical coordinates, go back to that. Let's let our little guy turning while we thinking about that. So the spherical coordinates is quite simple in fact. This is okay. So x is equal to the radius, which is 1, multiplied by the sine of alpha, so this is the main angle, multiplied by the cos of phi. Okay. Then y is again equal to r multiplied by the sine. I think this is the sine of alpha multiplied by the sine of phi. Then z would be equal to r multiplied by cos of alpha. Okay, so this is it. Then we would have something like r is simply 1, so we can get rid of this one. So our vector are basically sin of alpha multiplied by cos of phi, etc. etc. So we only need to find the angle. So if we find the angle in the two axes, we can sample two vector difference and two other different vector. So I'm sure there is a solution. We have the polar coordinate and the Cartesian coordinate, so it's more Cartesian to spherical coordinate. Okay, first thing first, we are knowing the r value. Okay, so r value is basically the length of our vector. So in order to refine it seems to be that. Okay, so in order to go back from Cartesian to polar coordinate, r is simply equal to the square root of x squared plus y squared plus z squared. Okay, but we know that because r in our case is simply the length of vertex, so we don't need to compute that one. Alpha is basically equal to the tan value, the atan, I think, yeah, it's atan. So tan x minus 1 to y on z, and phi is simply equal of the same of the arctan of square of x of square root of x squared by y squared divided by z. Okay, So by doing that, I could simply sample a little bit the other vertex position, scale them again, go back to the noise, and compute everything. It might be really expensive, although, but you know what? Let's try that. So yeah, HASL arctan. Do we have an arctan function? Return the arctangent of a specific value. I think this is. Yes, this is the arctan. I was not okay. I was correct in the notation. Okay. So we have this vertex. So let's try to write a function about that. So let's return this as the float 3. Okay. Float 3 Cartesian to spherical. Okay, it would take a float 3, which is our vertex, so we only need that. So we are knowing that simply float r is equal to the length of our vertex. We are knowing that because we know the we know it's a sphere, and I'm quite sure about that. Yes, this is the length of our vector, and the shape is basically at the origin. So now we could compute, let's say, alpha, which is basically the arctan of vertex dot y divided by vertex dot z, and of course float phi, that would be equal of arctan of, and now we have first of all the square root of vertex dot y multiplied by vertex dot x multiplied by vertex dot x plus vertex dot y multiplied by vertex dot y, and the square root would be divided by one, two. I don't need that. Okay, and this could be divided by the vertex dot z, and this could give us our little vector, which is r phi r alpha and phi. We need to know that this is returned between it's between minus p dot y and p by 2. Okay, so if we want, we need to sample this. It's the documentation of Microsoft, I think. Yeah, so we can define p somewhere, so let's put that. I'm not sure Unity has a p value, but let's define that. So let's define here a p, which is basically equal to that, not in the setup but in the Cartesian. So because it's between minus p dot 1, 2, it would be simply plus p divided by 2 to offset it a little bit, so to be able to return a value between 0 and p. Okay, so this is the main idea. So now I could get this little vector here. Okay. Do I need to scale them? I don't know. Let's say vert. Let's don't call it as a UV. Okay. And then don't scale this a little bit. So I will need, I think, multiple neighbors. So as you can see, we have this kind of text cell with taking 4 neighbors. So this is the noise of the 4 neighbors and the normalize the value. There is also another solution, but for that we will need to know the tangent. Hopla. And we could know that tangent by simply sampling 2 vectors and taking that. So let's try that one. Okay. Let's say flow 3 nay yes, I need that. Okay, so let's say flow 3 squared would be simply equal to the Cartesian to spherical, and we would take the vex. So this is the main idea. Okay, then we could have nay for tan, so this would be the neighbor for the tangent. Okay, and now I could say flow 3 spherical, spherical to Cartesian. Okay, and we will take a flow 3 spherical. So this is quite simple, we already know that. So dot x is equal of spherical dot r, this is the radius, plus the sinus of spherical dot y, the alpha, plus multiply by, so multiply and multiply by the cosine of spherical dot z. For the y-axis, it's basically the same, but it's sin instead of sin cos. yeah, and for the z, it would be only the cos of spherical dot y. Okay, so now we can return a new float, of course, which is basically x, y, and z, and which is basically a new float 3. Okay, so now I can say a2 tan, so this is the vector we need to change. It would be vert plus a new float 3, and we will not change, of course, this, but we will change a little bit the alpha, so I'm one vector, so it might be p.005, just to be a little bit, or 005, just to be a little bit near that. Okay, and 0, of course, because I don't want to change the other angle. Then a2 beta by multiply by 0.05. Oh my, oh no, OBS has crashed, Unity has crashed, everything has crashed. Okay, Unity crashed, OBS crashed, everything crashed. So oh, and of course, I think it's a crash from my card, basically. Okay, so this is back online. I also need to restart the stream. Let's hope we haven't lost anything. Okay, so yeah, I was going to this little thing. So this is na beta because this is the bitangent, so I need to, so this is my two near vector. So now I can simply say vert multiply by the scale UV. So this is vert noise. Okay, hopla. Let's go back here. Let's get rid of this one. I can simply also say tan noise, so I need to know the noise on the tangent, and of course the beta noise, because I need to know the noise on the bitangent, and this would take this one. Okay, so I have my tangent, my bitangent, I have my noise on the tangent and bitangent. So now I can simply, this is my vert displace. And basically I can also compute, so vert displace is basically this multiplied by this. Okay, so tan displace is basically this plus the normalized value of himself, in fact, because we know that the normal for each vertex in the sphere multiply by the tan noise multiply by its factor. So this could be that, and the by tan displace could be that. Look like unity is taking some time to going back on tracks, but it seems it's back on track. Okay, so this is that plus that plus that. Okay, so of course I'm normalizing the natan and the nay by tan here in order to take the normal, because we are in sphere, so basically the normal vector is the same as the vertex. We are we are in model space, so if I know the vertex, this is basically the same but normalized. So this is it. Okay, so before doing anything else like that, let's continue our little experiment on the lighting. So because I know now the vector of my tangent and bitangent, I can compute now clearly the correct tangent and bitangent, which are these two vectors. Okay, and I can take the cross product of them in order to recompute the normal. So basically it would be something like that. So the tangent is simply my tan displace minus my vert displace, and which is the same here for the bitangent, which is my bitan displace minus the vert displace, and the normal could be easily the cross product of that. So I could say something like v dot normal dot xyz is simply equal to normal, and of course this, because I have computed here, I can say it's simply that. And we could try that. I'm really not sure about this one. If we use a lot of instances, it might be really too much element. Oh yeah, I've used a v noise, but it's vert noise now. So I think it's too much process, especially if we use a lot of instances, but in our case, it might do the trick. So tangent and bitangent, we're only using 20-50 instances. Cross and declinifier by tangent, which is this one. Okay, let's cross finger. And of course we are launching the previous scene, because Unity has reloaded with all its previous saved scene. Okay, so we are back on track. Not perfect as I thought, but we clearly made an improvement on the lighting, I think. Not really an improvement, but this is kind of something. Clearly we have some spot which is not the correct one. Maybe we don't need that. There is different area when we might have a problem. Might come from the spherical coordinate, might come from a lot of places. And I think we are going too far on this little offset. maybe by simply saying something like that. Let me check everything. So it's R. So R is X here, so this is X, X and X. Y is basically, of course, this alpha, so yeah, which is basically that. Okay, so sin sin cos, sin sin cos, cos sin, so this is correct. Clearly not sure about this part, but let's try that. It was an experiment, so I was not sure about this idea, but as you could see, it's clearly not perfect. So let's think about that. On the same scale for everyone, and the time. So if we simply change that, Let me check. Vertex. No. No, 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 no. I've made clearly a mistake here. I've put the vertex, but I need to put the spherical coordinate, of course. Why did I make that? I've taken the vertex, but the vertex is not in spherical, so this is basically a big mistake. Yeah, now it's better. Not perfect, and we still have some error directly into the little guy here. But because this need to be also remap, not sure if we will be need to be remapped, but let's remap them just to test. Unexpected token. Did I made a mistake? Yeah, I've made a mistake here. It's pi plus 0.5 pi plus pi multiplied by 0.5. Well, clearly it's not perfect, and we have a lot of mistake into it, but it's a bit more interesting. So this that noise factor, this okay, target minus location, so this could be correct. So you could see it's clearly not correct. You have a lot of problem, but let's check if the problem comes from the rotation or not, because we have a lot of different things happening here. As you could see, we have a lot of problem in various area. Where is the point light? The point light is here. So it's taking the point light, of course. But not perfectly. Okay. Okay, so let's look into it. Of course, you take a position plus an offset, so this is correct. This plus the normal, and the normal is set the same normal for everyone, I think. Of course, this would not work, but let's try. Let's try. Let's try a little idea here. Basically, it would not work. I'm sure about that because I'm taking the normal and not the normal from our little scene here. So yeah, it's clearly not perfect. Okay. As you could see, it's clearly not correct. You could see how it's behaved. It's not interesting. Okay, so let's not displace the normal for a moment and let's try to rethink about that. We could take the average between the two, for example. So we could say something like this, that xyz plus normal, of course, and the overall divided by 2, but this would not be the solution again. Yeah, it's give us something, but not quite perfect. we're nearly to the correct lighting, but clearly this is not the correct one. So let's try to think. The way here was to sample, so this way we sample the 8. Okay. Wait. No, this is it. This is correct. My tangent and my bitangent are correct. Okay. So I'm not sure about giving more time on this. Let me comment this and say normalize normal computation from this is not working. Okay, so that gets rid of this little guy here. So this one and this one. We will go back to that in time. So on the clarifier tangent, of course, this is it. And we would check only this. Okay. So let's continue our little journey. So the idea would be to have some kind of jiggly sizing system. So to do that, we could again use the scale, so it might be only happen on the compute shader. Where is it? It's here. Okay. So the main idea is to change the size along a normalized position. So yeah, again, what do we want to achieve? So something that might be interesting is that having some kind of element going from up to down, you know, or from maybe from the left to right might be more interesting, going from something like it will like an effector which scale down and scale up the things, you know that. So let's try that. Okay. Do we need an effector like that, so it can go that. It might be interesting or not. think about that? We haven't tried something going from left to right. Okay, so first of all, again, let's try to work with some kind of base time for everyone. So we have that, and this is the position and this is the size. So okay, let's use some kind of a step, you know. So let's redefine the size. Okay, yeah. So let's first start with a step. So we will define this. So we'll use some kind of this will be the size of the target size. No, let's call this float animate size. Okay, we have already used a step, so we could use a step between two value. So first of all, we will need to normalize the position. So do we want to normalize the actual position? I think so, might be better. So you know what, we would take that, the size management, I will put it, so this is the angle, this is the offsetter, I'll put the time management below. Okay, so the float norm x is simply the position you need to remember the position is not only I need to rescale the position. So this is when we can use the word. In fact, does our shape, or does it behave the shape in the word? I made the variable during the first experiment. At the beginning, I've made a word variable, and the main idea is to check whereas how does the shape goes. So you can know that we are a little bit bigger, so let's put something like 2 by 2 by 2, so we could use that in order to normalize. Okay, so 2 by 2 by 2. Okay, so do we put something like that? No, we haven't. So let's use a uniform float 3, which will be our world. I need to put that in this. So compute dot set vector world is basically this vector. Okay, so now we can try to normalize our little position. So we need to remember something. The body is basically based on the gizmo on the center of the coordinates. So when we normalize the y value, this is easy because we know that every position is upper 0, is bigger than 0, but now we can have positive and negative x. So we need to offset this a little bit. So we need to take this x, okay, and offset by the the middle, the half of the word. So let's take this position and let's say position plus let's use a new float 3, and we want to offset on the x, so we would add world dot x multiplied by 0.5 0 0. So this is the offsetted word, and now I can simply say divided by word dot x, and I would have a normalized value for our x-axis. So we can simply try that by taking a step value, and the value we would take is, for example, the norm x, of course, and we would take, you know what, let's put the time, which is basically the norm time, sorry, which is animated. Okay, and in the edge we will put the norm x, and now because of this little step we could try something like size multiply equal by our animated size. Okay, so basically I would have something like big and 0 on the x-axis. So this would be our result if I'm correct. Identifier word, of course, because it's word with an underscore and a capital W, so it's word like that. Again, it's not working. I might be missing something. So this is word, it's a float 3, this is position, the position is here, and I forgot to change the second time I've used the value here. Step no magic to parameter function. Norm x, norm time might be correct. Okay. So now you see clack 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 and clack 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 clack, like a plane going from that. So of course we could use a ping pong time count going on. So go back to our little guy here. What we could do, yes, let's try to only use the SSS. I was thinking about maybe we don't want to use that, but okay. So now we have a value. That's okay. And this is the target size. So where is the target size? Okay, so we can use new value. So let's say float thickness. So now let's say that we want only to make something disappear on a specific position. So we will need a position, a thickness. Okay, so when we are at the center of the shape, I want something here, an area, a column, which will be empty. So I will need a position, which is the norm time, but I will need a thickness. So we need to say on this position plus a thickness. Okay, but the thickness would go up positive value and 2 negative values, so thickness divided by 2 plus a smoothness in order to have something a little bit smooth. So we need 2 values. First of all, we would say something like that, float thickness and float smoothness. So go back to this. Then we can use a smooth step value. So let's take the first one. So the first one is basically the norm time minus the thickness divided by 2 minus the smoothness. So this is the first part, so this is the negative part. Then the second element would be basically this. Okay, and I multiply by an invert of basically the same computation here, but we will take the positive value of this limit. So this is the thickness multiplied by 2, and then we get rid of minus the smoothness. We have the positive, so we would add the smoothness as the second component. Okay, so by saying that, we could end up with having a hole only on one. Okay, so I was saying that we would have a hole only on one column on our shape, but this is basically the inverse, in fact, because we need to invert the computation here if we want to have a hole. Here we have something, a reveal system, so if we are on this position plus the thickness and the smoothness, this will be something between 0 and 1, and if it's not, it's basically 0. But if I'm inverting this, I would have a shrinking system. Yeah, something like that. Okay, but it's really too messy, you know. So let's try to change that a little bit. First of all, we could simply this value, this animated size, we could create an out elastic function again, and we will use that with a value of 5, so in order to have some bouncy system in our multiplication. Okay, too much. Maybe 1. Way too much. I think I will need to recheck the way our something more like that. Tuk, 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 tuk. Okay. So it's now more interesting. Of course, we still have our problem like yesterday, but the fact that our shape are basically the base shape here are visible. So let's focus first on the bouncing. Okay, 12 maybe. I think we will need something slower. First of all, the animation is quite big. Okay. So of course we don't want to have our little guy here being at the size of 0 at first. Maybe it has its proper size, but it grow and grow down, grow and grow down. So maybe we could say something like adding some kind of little bit of noise, you know. So maybe we can simply say that the size is simply the actual size plus an increment, you know. It could be the same increment for everyone. So we could use an increment of 0, 1, for example, and let's say what's happened. Not big enough. I'm not sure about the x-axis, but I think it would be better to basically take the y, because we have more value on the y-axis, so it could be more interesting. So we could use a little bit of that and say maybe we want something going from 20 as a max time. So let's try with a basic size for everyone, the same size for everyone, and let's check how it's behaved. So it starts from the middle because we have offset the word, you know. So basically we could simply say that we don't want that, and we would take that directly in order to start from the ground. Let's use 0 and let's use 0.5 here, and let's divide this, and this could be simply say something like norm instead of norm x. So now you see how it's growing. So we can go back here, it seems to be better. Okay, and basically I think everything will reside on the Okay, now that's interesting. We could simply try to change the norm time, which is here, and let's say growth time, and I think this is really the time we need to put in this, and not the animated value, so this could be something like that. It could be more interesting because now the value is really between 0 and 25. Oops, made a clear mistake somewhere. Oh yeah, forgot this part. Okay, now it's really more interesting. So if I want to be really a proper system, it would be something like that. And then it would go back. Look like it's really taking some time. Change that. Okay, so yeah, we could simply now create a ping pong time, as we do a lot of time. So basically it will be the absolute value of the norm time multiplied by 2 minus 1 . We wait a lot until it seems to be going that way, but waiting a lot of time. It's doing that, and then it's waiting on the top. I'm not sure why. Let's check again. Yeah, because it's the time. So I'm scaling up the time, not the system. Okay. So of course the easing was better, but not as I thought. Okay. Okay. So now we clearly have the ping pong system I wanted. So where do we need to put the elastic system? I think it might be here, out elastic, and this of the size of 8. Okay, that's kind of correct. I think it's if I'm reducing this value, it might be not really interesting, but let's try that. It would be too jiggy, yeah. So we need to find a proper value which gives us some kind of nice bouncing. For example, 15 is not enough. Something between 10 and 12. Okay, now it's correct. Go back to that, go back to 10. Let's try that. Okay, and let's try to retake our based persona. I'm not sure about the base persona in fact, but you know what, let's try that. Zero 20, 0 30, 5, let's check. Okay, let's add more elements. Okay, I think it's okay. We need now to find some nice shader, not a shader but some nice you know, oh of course the size I would need to, this was my problem, a nice texture. So let's go back to some free PBR texture on CG texture and let's browse some of them. And I think I saw some of interesting fabric. Let's go back in the category. So fabric, okay, PBR texture. Go back to my little link. Where is it? The list, here it is. 3D texture, and I think it's CG bookcase now. Yes, this is one. Okay. Fabric. Let's find a nice fabric. This one might be interesting. This one not. Let's check what they have here. I think the silk might be interesting. Leather, no. This one is kind of interesting. This one not. This one is cool though. If I can find a white fabric directly, that might be better. Something like this one. This one is beautiful, and this one also. This one no. Okay, so we have some of them. So we might go from this one, or the silk. Let's start with this one. Okay, and let's say we want to download everything. Let's call a new fabric. Create folder fabric and show in Explorer. Yeah, I know. We're running out of time or not? I don't think so. Okay, where is my download? It's here. So let's take it. Okay, I put that here. And let's try this one. This is a normal map texture. Okay. We have a color, we have a normal, we have a roughness. So let's try that. Yeah, that was kind of the idea, having something like a nice place to sit. It's not the color I want, but I could say it's not metallic. We could add some variable because it seems we have a little bit of an occlusion, so it might be better to add the occlusion. So let's add that occlusion. We'll name this occlusion. Okay, and let's use a sampler to the occlusion. Okay, and this is the OCC. Okay. So now I can multiply everything by the occlusion. Let's also go back to our little fabric here. So this is this one. We could also try this one. But I'm not sure, it's more like a linen, so I'm really not sure about the linen. Yeah, it's really more interesting with this. Okay, this texture is really some kind of interesting one. So let's say know this, know that. Okay, so now we have a lot of elements. Put a little bit of metalness into this in order to avoid too many elements. So of course it will need something really blurry. 001, a little bit of emission. Something like that. And because we are a little bit too serious, we have the size of it is really too much, I think. I will need to simply change that by saying something like that, and also the normal might be changing. Okay, so now it's more interesting. Yep. Okay. We also have a little problem on the ramp here. So let's use Photoshop and let's change the element. So yeah, because we are going up some the RGB value, so I prefer to have something less emissive. Okay. I will need to change the color even if I'm really fond of this one, but because we already used this color yesterday, I think it would be better to change. So yeah, let's take the color here. Take the color texture. My main idea here is to take the color texture and to basically take this, put it in black and white, and use it as a multiplier of our color. This might give us the basically same effect than I think this would give us the same effect than the occlusion, but you know what, let's try it. It might also force the occlusion, which I don't want. Okay. So yeah, now it's really forcing the occlusion. But because of that, we could reduce this value a little bit, something like that. I think we would be able to increase a little bit. a little bit too gray. Let's change a little bit the level of this one to be more white. Yeah, it's more the look I want to have something more smooth. Yeah, it's better like that. You can zoom into the shape and you have this nice effect. We still have this one, which I don't know why we have that. Maybe because I don't know why we have two shapes which seems to be repeated. I might have a problem here. Look like two shapes are already the same. Okay, I think we have it. We can try to know more about to change a little bit the ramp, because the ramp is based on the albedo ramp on a UV, which is based on UVX, okay, which is basically based on the random value, in fact. Okay, so we know what, we can get rid of all this little part here and simply say something like that, 0 to 5, and this would basically be the same. Okay, now we are using all the ramp, and now we can change this. I think I would go to a ramp with a little bit of green into it. A little bit like this one, in fact. Maybe we can use this one, in fact. It's kind of an interesting ramp. Okay, let's try this kind of ramp, but let's change it a little bit. So we will open the two file. Okay. Okay, I want this color here. on this part I want this one, and 25 I want this one, on 75 I want this. So I think I'm okay with that one, and we need on 50 this color. Okay, so this is the base drum, but we want to put a little bit more saturation into it, maybe. A little bit of white, maybe. Maybe another kind of yellow, which could be less watercolor or pastel, maybe a little bit more to that, something like that. You know what, let's try this one. Not sure about it, but let's try this one. 25, it's okay. So here we are. Okay. Does it change something if we change the sphere with someone which has more vertices? Yeah, I think it's good. I kind of like this color scheme, and I think we have some kind of nice little bubble man which has some kind of deformations, etc, etc. So I think this would be good for tonight. Okay, I hope you like it as like this one. Again, we've reached some wall which are no wall, because if we want to dig into it, we can pass few hours to think about it and find a solution about proper lighting and recomputing the normal. But as I prefer to always say, it's if the looks seems good to you, why do you need to fix the lighting? Why do you need to fix something if it looks good? If the animation, if the shapes, if even if we have still a little bug because it's not perfect, then you have some little glitch somewhere, but if it's feels good for the viewer, for the spectator, I think it would be good to keep it, because if it works, don't break it. Basically, this is the main idea. So yeah, I hope you like it, and see you tomorrow for another round of this Code Vendor. See you guys, bye.